Geometry lesson 8-1. We're going to look at some proportions now and how we can use proportions to solve. So one scenario for proportions is when we have a triangle and there's relationships comparing the angles of those triangles. So measures in a triangle are an extended ratio of 3, 4, 8. Find the measures of each angle. Now, what this is saying is that for every 3 degrees you have in one angle, you have 4 in another. And for every 4 degrees, you would have 8 in another. There's for every 3, you would have 8 in the other corner. So there is a relationship between them. For example, if one corner was 30 degrees, the other one would be 40 degrees, and the other one would be 80 degrees. But we're dealing with a triangle, and the whole triangle must still total 180 degrees. So what you can use is you can use a model with the triangle and go ahead and put your extended ratio in it. Now, I don't know if this triangle is exactly how the shape should look. I'm just drawing a triangle so I can get a visual of what's taking place. Drawing a picture is a very good problem-solving strategy. Now, I put the multiplier in here because I'm not sure what they all are going to equal, but I know the relationship is 3 for every this is the same as 8 for every of that x, and then 4 for every one of those x's. But the grand total is that all of these angles must always add to be 180. So I can take it and say 3x plus 4x plus 8x still has to equal 180 degrees. Since these are all like parts, 3 and 4 make 7, and 7 plus 8 is 15. I have 15x is equal to 180. All I need to do is now divide by 15 to get x alone. And 15 goes into 18 one time, with 3 left over, making this 30. 15 goes into 30 2 times. So x is equal to 12. Now that's not the measure of the angles. I need to find the measures of each angle. So this right here would be 3 times 12, which is 36 degrees. This would be 4 times 12, which is 48 degrees. And then I can either multiply 8 times the 12 and get my answer, or I could take these two and add them and subtract them from 180 gets the answer. Or I can say, well, 8 is twice as much as 4, so I can double that. It doesn't really matter. But either way, 8 times 12 is still going to equal 96 degrees. And I now have all 3. And the relationship is that for every 4 of these, I have 8 over here. So in other words, it's twice as much. And 96 is definitely twice as much as 48. If you add 96 and 36 together, then you end up with, this is basically 100 plus 32. So 132 plus another 8 makes 140. And 140 plus 40 is 180. So the relationship works. If the relationship extended ratio is something like 2, 5, 7, then I'd put 2x, 5x, and 7x into this triangle, and I would solve it the exact same way. That's all you have to do. It's pretty easy to solve. A concept known as the means and the extremes. Excuse me. You have 2 fractions. If you have 2 fractions, then the top of one and the bottom of the other we would refer to as the means, and the top of the other one and the bottom of the other as the extremes. And it doesn't make a big difference about which one. You just need the top and the bottom of one, and that's the means, and the top and the bottom of the other, and that's the extremes. Whether you flip-flop the fractions, it really doesn't make a difference. But what we do know is that the cross-product property states that any product of the means is equal to the product of the extremes. In other words, if you take these values, which are the means, and you multiply them together, they will equal the extremes multiplied together. Always. If you are truly dealing with 2 fractions that are equal to each other, then the top and bottom of one multiplied together will always equal the top and bottom of the other multiplied together. And that's the cross property. Cross-product property. The reciprocal property, if 2 ratios are equal, then the reciprocals of each are equal. So here we have a situation where we know for a fact that A over B is equal to C over D. I'm saying they're equal, so therefore they are. The reciprocal property states if you flip one fraction and you also flip the other fraction, they'll stay equal. And that's what we have. If you want to look at it with numbers, you could always say 1/2 is equal to 4/8. And that's definitely true. Well, 2 over 1 is no different than 8 over 4. Both of them are equal to 2. Both of these are equal to 1/2. So they are definitely true. If you need some proof on this one, if you were looking at the 2 fractions that were equal, 1/2 is equal to 2/4. It means 1 times 4 is definitely going to equal 2 times 2. Both of them are equal to 4. So that works on the cross product property. Alright, a couple examples. If we want to solve, the means and the extremes should be equal. So therefore 9x has to be equal to 14 times 6. So that means 9x is equal to, if you multiply 6 times 10, 6 times 10 is 60 and 6 times 4 is 24. You add the two together, it's 84. Now you divide each side by 9. Now 9 goes into 81 exactly 9 times and leaves 1/3 left over because it leaves 3/9, and 3/9 simplifies down to 1/3. So there we have our answer would be 9 and 1/3 right there. Another example, this is a little trickier. You need to put parentheses around this. And you're still going to be dealing with the means and the extremes. So 4s is equal to 10 times s minus 5. So I change that to plus the opposite and I would distribute. So now 4s is equal to 10s plus negative 50. And then the shuffling game is on. Probably easiest to get all the s's onto one side. So I would go ahead and subtract or add negative 10s. And then I'm left with negative 6s is equal to negative 50. So I'm one step away. Divide by negative 6. And in this case, negative divided by a negative is a positive. And 6 times 8 is 48. So I'm 2 away from the 50 that I need. Right? So I'm left over with 2 over 6, which again is 1/3. So 8 and 1/3. But again, it's all based on the idea of the cross products, enabling myself to solve these proportions.